Stand by. Shooter ready.
Stand by.
All right, welcome back to another episode of the PRS podcast. We decided to take a show on the road this time. We're just on the road from where I live, and actually right next door to where I used to work. We're here at Vortakt Barrel Works with my friend and coworker from ex-coworker. Yeah, sounds bad when you put X on it, but that's okay.
Yeah.
Previous coworker,
Yeah.
Chad Weister, the manager here at Vortakt Barrel Works.
Yeah.
So,
Yeah.
good
Thanks for
morning,
having me on, Ken.
Heck yeah.
Appreciate it.
No, this is exciting for me. I previously worked in engineering, and in 2019, I think I started at Unisig, which is a machine tool manufacturer that's next door.
Yep.
At the time, actually, Chad and I think actually you just transitioned out of engineering, didn't you?
Yeah, kind of. And we were still in that building.
Yeah, exactly.
Yeah, we were still in the West building. So we were transitioning, or we hadn't purchased this building yet.
Right. That was maybe a year later.
Yeah.
Yeah.
It was soon after. But.
Yeah. So I was the engineering manager in Unisig, which we make machine tools, deep hole drilling machines, which most people assume like deep hole, like that's drilling holes in the ground, right?
Right.
Oil, natural gas. Not at all true. It's more, think gun barrels, right? And that's a big part of the Unisig business, but it's anything from small little medical drills up to cannon barrels that are 40 feet long, right? And have huge bores. But so I was the engineering manager, and at that time, Vortakt Barrel Works was still coming out of what would you say, like an R&D development kind of engineering lab, right?
Yeah, I mean, kind of the way it started was because of the Unisig business, of course, right? So we had built a lot of, we being Unisig, had built a lot of gun drilling machines, and we were really good at that. But we were kind of missing that firearms industry market. Yeah. So we had customers coming to us in the firearms industry asking for a reaming machine, a rifling machine to kind of complete the set. So we embarked on that, and our owner, put in a lot of R&D funds to develop the process, so we understood it, so we could build the really, really good machines for it. Yeah. So
not just building machines, but understanding with the tooling and feeds and speeds and all of that behind it.
Right. Because everybody that gets into it, or OEMs, some of the OEMs knew how to do the process, but a lot of people that were getting into it didn't know it. So we had to give them the process.
So
and
like a brand new manufacturer of like ARs, right? They knew how to make ARs.
Right.
They're probably sourcing their barrels from somebody.
Right.
But then they go to buy equipment, Unisig equipment, and they're like, well, what do we do with this? How do we, if you buy a CNC machine tool, you get application help with that and all that, right? So that's kind of where the business was, right?
Right. Yeah, I mean, it kind of, and so we had a couple larger OEMs come to us looking for machines, and I was kind of in the middle of developing a lot of the machines and the process and doing project management and everything. And we then had some smaller companies looking to get machines in the future. And they're like, hey, is there any way you could make barrels for us? and it just kind of like, it was like, oh, there's a business case for this, like a professional barrel manufacturer. So we set aside some machines and we started doing some contract work. And it not even slowly, it grew fast. I mean, it really grew fast. And then, a building came available, so we bought the building and moved all the machines over there, moved the business over here, and we just keep growing. And so we use a lot of automation, of course, and things like that. But that was kind of the backstory.
So it's important to note here too, and this is the Precision Rifle Series podcast. And I'm really excited about this because I love coming back here. I grew up in engineering, and I spent 20 some years in engineering, and I honestly thought I was going to retire from Unisig. I was jacked to have the role that I did, and I was excited to be there. And then the opportunity with PRS came up, which is an awesome, exciting opportunity. But
and you like getting free barrels.
Who doesn't like free barrels? We have a lot of amazing partners with the PRS. It's important to note that the machines that we're talking about here, that aren't that 1940s, 1930s, like Pratt and Whitney, very mechanical, slow drilling, et cetera, right? Like these are very modern machines. So that small company that says, hey, we're interested in purchasing Unisig machines down the road, but right now we need a good supply of barrels. They probably could go out and spend $10,000, $20,000, $30,000 and buy those old machines and retrofit them, and then but I think they understand the value of having modern era, high technology, very fast, very accurate. These are exciting machines to engineer and use to make barrels.
Yeah.
Right?
Yeah, and throw automation on top of it.
Tons of automation. That'll be cool. We're gonna talk here for a little bit, and then we'll go do the field trip. But I'm excited for you guys to see that. Like I'm like almost joyful every time that I get to walk through here.
Yeah. So. Yeah, and us being kind of the beta site for all new automation, because we being Vortakt, we're developing a lot of the automation based on what we're learning from making the process. So a lot of times we'll develop something, develop equipment, develop automation, get it deployed, and then it becomes kind of mainstream. So what we have out there, honestly, is some of the highest technology barrel making equipment, I'd say, in the world.
Probably.
I mean, it's pretty cool.
I think that's accurate. I've been to a lot of barrel makers, and everybody does it a little bit differently and has their own way and their own flavor and all of that. But yeah, definitely the highest level of technology and efficiency and all of that. It's cool.
Yeah.
So let's talk the barrels for a second. Obviously, so I brought one of our demo rifles, MDT ACC Loophole optic. It's got a silencer co scythe on there. Diamond, TriggerTech Diamond. Very, very awesome rifle, and a Vortakt barrel on here. Can you tell us about this barrel, and then tell us maybe more about the different offerings of Vortakt barrels?
Yeah. So I think when we built this one, this is probably a 6.
This is a 6 GT. I should have been.
Yep.
Which you guys chambered here too.
Yeah.
You did the whole deal. Yeah.
Yep. So I mean, for us, it's a 6mm barrel blank. It can be chambered in whatever you want to chamber it in. But this is one of our 400 series barrels. So we have essentially 5 different series barrels. It just kind of goes up from 100 being more economy. Still a really good barrel, but it's more of your AR type product, AK type product. And then 200 is our kind of our standard production barrel. Very good for ARs, and it's good for bolt guns and more of your, let's say, $1,000 to $1,500 rifle. And then 300 series, we slow the feeds down on all the machines, and it gets you a straighter hole. And our finishes are nicer. We switch out the tools more frequently, and then we do a light lapping to them. And then like this one is a 400 series. So I guess to step back a little bit, 100 through 400 are all button rifled. So that's kind of solid carbide tool, and it's forming the rifling all the way through. So it generates a lot of heat, a lot of load, and it just cold forms the rifling in it.
Which does, you have some residual stress after that process, right? Which is also cool because after that you have to do a stress relieving process, right? Which for the longest time happened at a outside supplier, but the investment was made to do all of that in-house now too. So like soup to nuts, 100 to 400 series barrels, all in-house, right? Awesome.
And it was that was a huge investment because that was a $600,000 furnace, and a $300,000 install with all the options and everything. So that was a huge investment, but. We try to control everything in-house. That's awesome. And it's fun too, right? Because I'm an engineer too, and we really enjoy developing all those processes.
Completely vertically integrated.
Exactly. But so that 100 through 400 are all button rifle barrels, and then that cold forming puts a layer of stress on the inside. So we put it in that furnace, take that stress out, and then we can contour it. And then 500 is our cut rifle line, which we don't push a ton just because we're doing a lot more volume. And we were doing hundreds of thousands of barrels a year.
That's crazy. Probably though, I mean, as an independent barrel maker, very, very likely the largest barrel maker in the world.
I haven't probably done enough research on that,
Yeah.
you know, but yeah, we make a lot of barrels. You know, I mean, there's other OEMs
Yeah.
that make a lot of barrels, of course, probably more, but as a contract manufacturer, we've got to be up there.
Independent,
Yeah, and you know, I've been trying to move as much as we can overseas and stuff like that. I mean, sell product where we can overseas, but those markets just aren't anything like America.
It's different. Yeah.
It's crazy.
Yeah, here, and obviously this is an international podcast, but here in the U.S., like, we love guns.
Yeah. Oh yeah.
And we shoot them enough to replace barrels on them.
Yeah. So yeah, then we get into the 500 series, but yeah. So this is a 400 series barrel.
Yep.
The 6mm are they're lights out.
Yeah.
I mean, you shot them a lot.
This 6GT, it just is a hammer.
Yeah.
Like, it shoots very, very, very well.
Yeah.
Yeah.
Yeah, we really like it. So.
Yeah. So a couple barrels in front of us here. I mean, I guess kind of explain this. This is a cutout, so, you know, obviously the chamber wouldn't be exposed on a, you know, production barrel, but.
Right. Yeah, we've machined that out just for trade shows and stuff, but.
Yeah.
Yeah. So this is a 8.6 blackout barrel.
Yeah. Shorty, love it.
Yeah. So that's been really popular for us.
Yeah.
And the rifling in it is 1 in 3 twist. So like when you
really
look
fast.
when you look down it looks like a screw thread.
Yeah.
It's really strange, but we've actually run them even faster than that.
Yeah. Like 1 in 1.
Yeah. That isn't in production, but but this is a very unique barrel. But this one's got a lot of contouring in it, so we actually, and we'll look at this out on the floor, but we use a lot of probes to check a lot of features as we're going. So we actually will contour this complete in one setup.
That's awesome.
Which is really cool.
So, and what you mean is that's coming from drill, ream, rifle, stress relieving, all of that, and it's probably that long, right?
Yeah, about an inch longer than this.
Yep. And it's that raw blank that I think, you know, most PRS shooters are used to seeing, right? Where you just get a straight tube and it's like, yep, this is I got to take this to my gunsmith. But then you guys take it from there and do all of that contouring and finish work.
Yeah, that's a good point. I mean, you know, I keep thinking outside of the PRS world, but in the PRS world, you know, it's typically going to be a barrel blank. But it's good to kind of point out that a barrel blank typically is the drilling, the reaming, the rifling, and then that stress relief.
Yep, and then good enough. Give me that barrel. I'm going to give it to my gunsmith. Leave it no taper.
Yeah, exactly.
You know,
like that's like this. We don't really do much to this. You know.
Yeah.
But this one's obviously a little bit more extreme when it comes to the contouring and threads, 3 threads. So it's a little bit more crazy, but this one's kind of neat too. We've been doing a lot more carbon wrap barrels. We don't do the carbon wrapping here. That's not really our thing. But we'll do all the turning and the blank, obviously, and it's kind of neat. You know, you actually want to keep this rough.
Yeah, for the carbon to adhere to.
Yeah. So that's why it doesn't necessarily have a great finish here, but we don't care because we're going to carbon wrap that. But I know this particular barrel, you can tell it's been shot. We were just kind of curious talking to a customer, and we're like, you know, he's like, hey, how well do they shoot without the wrapping? And we're like, it better shoot.
It's just, I mean, it's the steel of a barrel is what makes it perform. Period, right? Like, I mean, the carbon wrapping gives it a nice OD and maybe a little more structure, but I mean, the strength of the steel is going to be far that than the carbon, right? So.
Yeah, I mean, I don't want to knock like any of the marketing and the application that's gone behind people that carbon wrap, because I haven't done the math on it, you know, but I just know that when we send something like this out, it's got to shoot on its own.
Yeah, exactly.
You know, it definitely has, and this barrel shot phenomenal. This is a 308, but 5R, but it shot awesome. You know, so the carbon wrap, even in its steel form, shoot awesome.
That's
which is nice.
Yep.
Very important.
It is important. Yeah.
Yeah. And that's just a finished hunting profile that we have. So, but that'd be an all steel barrel.
So let's. Where are these going, right? Because I know that we're going to have viewers that are like, oh, cool. You know, maybe I've never heard of Vortakt. Like, how do I get a Vortakt barrel?
Yeah. That's always a tough one.
It is different, right?
Yeah.
So most of your customers, or almost all of your customers, right, are OEMs?
Yeah.
Okay.
Yeah, like we kind of have like a minimum, and I'm not trying to sell or anything like that, but we've got like a minimum order of about 50.
Yeah.
So typically have one SKU. So
sure.
you
if
know,
I wanted this 6mm barrel, I'm ordering 50 of them at a time.
Yeah. So we've had like PRS guys come to us and kind of group buy stuff, and then we have other OEMs that aren't super huge, but they're big enough to justify buying 50 6mm, 50 6.5s.
Yep.
And typically they take it in a blank form, and then they'll chamber it in multiple chambers. But you can't go to our website and necessarily buy a barrel.
You can go to the website though. Like,
Yeah.
I mean, I've tried to help a friend out here.
Yeah.
Obviously, somebody that I used to work with here. But so I don't want to sound salesy or anything like that. But this is exciting stuff. Like when I work next door, like it is super cool being a part of the firearms industry, but also still being in engineering and machine tool and
I missed the weekly. Ken and I would have like weekly discussions for an hour and a half about accuracy or, bolt
process.
lugs and stuff like that. Like what's accurate, and I kind of missed that. But
if my old boss Anthony or Corey are listening, we did not do that hour and a half talk. Like,
that's work. That's business. Sure. I mean, honestly, Ken helped a lot. Knowing the PRS world, he helped a lot in us but knowing what to use to get super accurate measurements on testing barrels, right? Yep. So honestly, when we're going to test something, we're typically going to use a PRS setup. Mm-hmm. Like I've used different things, I've tried different things, and when I go back to the PRS, like this type of build,
MDT, ACC,
it just shoots.
It does.
It just shoots. Like you're truly testing the barrel. You're not worried about the action, the chassis. Everything is rigid, and so like hats off to you guys for what you're really pushing the limits on things. It's cool. It's really cool.
Yeah, it's fun to be a part of.
Yeah.
So
and you taught me quit shooting the big Magnum stuff. Get to that 6mm. It ruins you. And you're right.
Yeah. I don't like recoil.
Yeah, I know. I try to stay away from it now too. But.
Yeah. So the cool thing about this, we're gonna transition out to the shop. We're gonna kind of walk through things and hopefully get to show you all the sort of nuts and bolts of what it takes to make a barrel. I know that nobody has seen barrel making this way, so I'm excited to be a part of getting to show it off. Yeah. The technology and the automation that's into this is super cool. I know a lot of our members, a lot of the folks that shoot PRS are, there is a stereotype, there's personality, and it's typically guys like you and I that get excited about this type of thing. Farmers, engineers. I know a lot of pilots that shoot. Like it's guys that are into it. So personally, I'm really excited that we can tour the shop. So.
Yeah.
Thanks for having us here.
Yeah. Appreciate you coming in. So let's get out there, huh?
Let's go.
Okay.
All right, Chad. We're out here in the shop now. So this is still a relatively new facility, right? Like this is maybe 5-6 years old.
Yeah. I mean, the facility was always here. Not always, but from the 80s or something. But when we bought the building, it was more cold storage.
Yeah.
So we actually went in, took everything out, painted all the walls, put in all new electrical. We kept the floors, but we kind of redid all the lighting, so it was a big deal.
It's a really nice shop to work in.
Yeah.
All right.
HVAC.
Yeah, exactly. Yeah, that is a bonus, right?
Yeah.
So we're here in front of the cell 1, you call it, right?
Yeah. Yep.
So these are the Unisig machines that we're talking about. We drill, we ream, we rifle, all right here in this cell, right?
Yeah. So this particular system, it'll drill and ream, and it's going to be tended by a robot.
Yeah. That's awesome.
We manually rifle here, but essentially what we do, because this is all automated, we just let it queue. It'll queue and queue and queue it'll like queue for a shift, and then we'll have somebody operate it for a shift to rifle it. Whereas a manual cell, you'd have to obviously man it the
you got
whole
a guy pulling out of the drill, putting it in the reamer, and then reamer to rifle.
Yep.
Yeah, and here it's just a rack, which actually the robot working right now is pretty cool. So it just grabbed 2 barrels out of the rack, and set them in the drill, and then that thing it clamps the barrels up. At this point it's just a bar of steel, right?
Yeah, it's just it's pure raw material.
Yep.
So it's cut to the length that we want, and then we've got chamfers on the ends, but it's just a raw bar.
Yep. With chamfers.
With chamfers.
So that gets clamped up, and then now we're drilling, right?
Yeah. So we rotate the workpiece one way.
Yeah.
And then we rotate the drill. I got a drill here.
Yeah.
And then we rotate the drill the opposite way.
Right.
So, and you know as much as I do about gun drilling,
So this is cool, right? So a lot of people, when we think drilling, you think of like using a Milwaukee hand tool or a drill press or something like that, and it's just a drill spinning, right?
Yep.
And that drills a hole.
Yep.
But the downside of just spinning the drill and holding the workpiece stationary is that drill, and anybody's done this at home, that drill wants to move and go different directions, right? And you're putting a lot of force, and that thing's going to flex. The drill is anyway. Yeah. And then alternatively, you can do it like what we do on a lathe, right?
Yeah.
Like what most of our gunsmiths would do, right? So you're turning the workpiece in a drill, or if you're chambering a barrel, the chamber reamer is stationary.
Yep.
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 But when drilling,
and that's a little bit better than rotating just the tool.
Yes.
The workpiece rotation is a little bit better than tool rotation.
Yep. And then cat's meow, or the best way to do it.
Yep.
Right. Well, I'll say best, the most efficient way to do it, and give you really straight holes.
Yep. Yep.
Is to turn the workpiece one direction, turn the drill the other.
Yeah. And right. And typically you're going like 1/3 of the speed on the workpiece.
Yep.
2/3 of the speed on the drill.
Yep.
But for example, like if you're running tool rotation only, you're going to run barrel type material at like 1 inch a minute.
Yeah.
Whereas if you could do counter rotation, you're going to run like 2.5 inches a minute.
Yeah.
So 2.5 times the output.
Right, and likely getting a higher, more straight hole.
More straight hole. Yeah.
Yep.
So counter rotation is a very big deal when it comes to gun drilling.
So let's actually talk. Again, we'll get a little bit technical here for a second, because I think our audience probably would appreciate it, right? When we're talking a straight hole, right? The hole inherently with most gun drilling processes is straight, but it's also your run out on each end, right?
Yeah.
So on the let's just take an example, like a 30 cal hole, right?
Yep.
Which you would drill. If the finish is supposed to be a 308, you're going to drill what, 290, 300, something like that.
Yep.
And then you're going to ream a little bit away, and you're going to rifle, and it's going to change size. But so like a 290 diameter hole.
Yep.
How on center is that on the entrance, typically?
Typically, it's going to be, the average is going to be like 3 thou.
3 thou.
Yeah,
so it could be anywhere from
TIR.
Perfect to 5, maybe max,
tolerance
right?
might be 5.
Yep.
But typically, your average is going to be right around 3.
Yep.
So really good entrance run out.
Yeah,
So
really
that's
good.
typically another good point. That's typically the end you're going to chamber.
Yep. So we're going to drill this way, and that's going to be your breech and your muzzle.
Yep.
In the end, so we kind of follow it through the whole process that way. Yep.
Every tool and then the bullet all goes kind of the same way.
Yep.
So
Same direction.
Kind of makes sense that way, but so on that 30 cal.
Yep.
Let's say it's 20 inches long, 25 inches long.
25, perfect.
25,
We're going to finish this at 24. It's
24, which is a very common thing. So I would say your average run out's going to be around, let's say, 12 thou.
On the exit.
On the exit.
Yep, on the muzzle end.
That's with counter rotation, new machines, gun drilling oil, all
good tooling.
things.
Yeah, I mean, you have everything dialed in. Yep.
That's 12 thou average. I'd say we would max see 20 on a barrel like that in stainless.
Right.
So,
but all that, and this is the special thing about this, right? Like when we get to the end of, after it's been contoured, it's 0, right? Because we're gonna pick that barrel up. Now that's a straight hole. It's a straight hole. Now it may have drifted from say 2 thou off center to 10 thou off center.
Yeah.
But we're gonna pick up on that hole
Yep.
and contour the outside. So in the
Yep.
end, you put that on a lathe and you measure total indicated run out,
Yeah.
close to
It'll be
0.
Close to 0.
Yep.
Yeah. I mean,
Yep.
couple thou,
Yep.
maybe at the worst case, but yeah, you use a center in one end and a center in the other.
Yeah.
You use a face driver or whatever you use to drive the part, but
Yep.
you always pick up on those. The best way to do it is pick up on that bore
On the
and then
bore,
turn
yeah.
the whole OD true.
Yep.
So yeah, you're taking any of that run out that was from the gun drilling process out.
Yep.
And there's no way around that. Like, you're
Yeah.
always gonna have some run out from gun drilling.
I've seen some perfect gun drill.
Yeah.
But it's like way less than 1%, right? Where you gun drill a hole, and it could be in a barrel, or it could be in a medical workpiece. It could be in anything where you put that on centers and you go to measure it, and you're like, no, this one's perfect.
Yeah. Gun drilling's weird.
Yeah.
It's like, I mean, you'll if we run 50 parts, 5 out of those 50 might be less than 2 thou exit run out.
Exit run out, yeah.
Exit, I mean, just crazy,
Yeah.
right? But then some of them will be 15.
Yeah.
And that's why I never look at like sample size of 1 when
No,
you
you
gun
can't,
drill.
yeah.
You look at 10.
Yeah, exactly.
At least 10,
At least
and you
10,
say
yeah.
whatever the average is.
Yeah.
So,
Yeah.
but that counter rotation is huge as far as feeds.
Yeah.
And then also run out.
Yeah, I mean, talking about those old Pratt & Whitneys, right?
Yeah.
They, which are great machines. It's old, heavy iron. Man, we as Americans, we built really good machines back in the day, right? And those, they're still useful.
Yeah.
But typically, you're running workpiece rotation only. So the gun drill is static. It's just fixtured in, and you're running maybe an inch per minute.
Yeah, typically that's what I've heard or seen is
Right.
1 inch a minute.
And I'll point out, it's on one spindle.
Yeah.
You probably have one
typically.
spindle that's running, where being able to counter rotate, like you can run 2.5 inches a minute.
Yeah, that's kind
plus
of
or
our
minus.
standard feed is 2.5.
Yep. And we're doing it on 2 spindles.
A twin spindle machine.
Yeah, twin spindle
Yep.
machine, typically, right? I mean,
Typically, yeah. It's a good size machine.
Yep.
I guess one other thing that's unique about us is we're doing everything kind of in single part flow.
Yeah.
Right?
Yep.
We don't have a gun drilling department, a reaming department, a rifling department.
Yeah, it all happens right here.
We also, we like to
it's all happening right here.
Yeah, we like to get down to that barrel blank all in one little spot.
Yep.
We just find it's less room for error,
Yeah.
less room for issues. You don't have that queuing, you don't have that handling. It
Yep.
just kind of all happens. So we like that. But
Yeah, you're not gun drilling a batch of, I don't know, how much one of these boxes hold, potentially?
the spec is 3,000 pounds.
Yeah, so,
But-
yeah, I mean, you can have a few hundred barrels in here, and you're not going to gun drill them all and then go set them on the shelf.
Right.
And then you're going to bring them back and ream them. Like, you just soup to nuts. Like, they go in the bar feeder as a broad blank.
Right.
They come out over here, and these are reamed, right? So inside the
Ream,
cell.
yeah. That far machine is
Yep.
doing reaming right now.
Yep.
So we
yeah.
kind of have like a 2-to-1 ratio. 2 drill spindles, 1 reaming spindle.
Okay.
And that's a good ratio as far as feed rates.
So about, so the reaming could be said as like twice as fast.
Yeah.
So.
Yep.
Yep. Okay.
And we're pull reaming. That's
Pull
when,
reaming.
You know, you
All right,
put.
so explain that. You gotta have a tool here. What are we doing when we're pull reaming?
So this is a common pull reamer.
Yeah.
Essentially, we're pulling it through the barrel. So when we go from the drill to the reamer, we actually flip the barrel.
Yep.
So the entrance of where we gun drilled is now kind of on the far side of the machine.
Yep.
And that tool gets loaded automatically on that machine
Yep.
and then chucked, and then we pull it through the barrel.
So to me, this looks kind of like a chamber reamer, but it's straight, right?
Yeah.
It doesn't have that bottleneck shape, and it doesn't have obviously the the small throat or anything like that. Yeah.
Yeah, and this we're taking 5 to 10 thou out
Yep.
total.
Yep.
So not a lot.
So the gun drill hole looks awesome, right?
Yeah.
But it does have
Ish.
a little. Yeah. I mean, to the naked eye, it looks awesome,
Yeah.
right? You look down a freshly gun drilled hole, and it looks like a mirror the whole way down. after we pull the reamer through, like it's almost perfect size and like perfect finish now, right?
Yeah.
Whereas the gun drill does leave a little bit of surface finish or texture, so to speak, right?
Yeah, and like, it's a good point, because when we first started this, I'm like, why are we reaming? So we tried to skip that step.
Yep.
I said, well, why don't we just go from drill to rifle?
Yep.
But you'll find that conventional gun drills, at some point, you might have a tighter bore.
Yep.
Or you might get a chip caught in that carbide, and it'll give you a ring.
Yep.
So you can do it. You can go right from drill right to rifle.
Yeah.
But it doesn't give you that perfect finish. So we don't skip the step. And the reamer finish really gives you kind of a mirror all the way through.
So I'm gonna throw a curveball at you too. We didn't talk about this, but some folks like to hone as well, right?
Yeah.
And that gives you a really good finish as well. And honing just takes off like way less material per pass, right?
You usually like, you run it pretty quick.
Yep. Back and forth. Yeah.
Back and forth, and you're taking in total 1 to 3 tenths.
Wow. Tenths. Way less than a thou.
Way less than a thou. Way less than a thou. And we don't hone here. It's a good process. It gives you a little bit like of a crosshatch finish.
Yeah.
There's value in it. We just try to perfect the reaming process.
Sure.
So I guess another good point is, like, the Pratt & Whitneys aren't bad machines.
No, they're good machines.
You can make super high-end barrels on the Pratts with this same process. It's just trying to make thousands. It's really, really tough. But honing is a great process. We kind of more elect
it takes more time.
It takes more time. We elect to do more lapping, because a hone is still going to follow the bore.
Sure. Just like that. So that's why you pull ream, right? Because that tool is going to follow the center line of that drill bore, right? And you're not pushing it, which might,
it might stray a little bit. Generally, when a tool's in, tension like that, it's a better process.
Awesome.
So. So, we're right now, Richard's actually rifling some of the barrels in this machine.
So they go in as raw steel blanks. They're coming out. These things they're actually a little bit staggered, so you can tell what spindle they came off of too. Then, right? Yeah,
we know spindle 1, spindle 2.
Exactly.
Which can be important if you're trying to troubleshoot an issue with
maybe a tool or something, or pressures in the machine or anything, right?
And one thing we've learned, I think you and I have talked about it, but like the black magic that people always talk about in barrel making, honestly, what I've found, a lot of it is reaming. It's just getting a good finish after that ream. So we've developed a lot of different style tools for reaming, and really tried to perfect that, different coatings, different carbide.
These reamers aren't ones you're buying online. You're not calling up PTG and saying, hey, I'll take another one of those reamers. You can do that, but it's not going to get the same performance we're talking about here.
Right. I mean, the stuff we're getting is all pretty custom, very custom.
It's experience. I mean, you make a couple 100,000 barrels a year, you figure things out on your own.
You naturally do.
Right.
I mean, we've broke a lot of tools.
I've broken a lot of tools.
Things. But that's how you learn, and that's how we can do what we do. But actually, here's the
this is pretty cool. So we're hydraulically pulling a button through, and again, we're still breech to muzzle, right? The muzzle is clamped up in the chuck there. And because we're pulling the tool, it's going to follow that bore, right? We're not just pulling it straight through. The tool has the twist built in. And the machine is also twisting, right?
The machine's got a servo, so it's a driven head. But like as an example, this one's pulling at like 5,500 pounds of force.
That's cool.
So there's a lot of load. There's a lot of load in there.
What size diameter bore are we talking here?
This is a 458.
Okay.
So this is
a bigger one.
This is like for that, it seems like the lever action is getting really popular right now. So this is actually, we're doing thousands of these. This is 410
precision
stainless.
Lever actions.
It's super popular, but we're all about it. So then once it's rifled, now you have that stress in it that we talked about.
Yep, and we have a bunch of lubrication here that's put in there, so the operator's pulling them out of the machine here, puts them in a rack. So what's he gonna do with this here? Because out of this cell, this is the only manual process, right?
Yeah.
Grabbing barrels, putting them in, pulling a button through, and then clean them out.
Yeah, we clean them out. Yeah, we get them real clean. We go into a rack that's going to go in our furnace.
Yep, that's this here, right?
Yep.
Cool.
So then it gets that stress relief.
Yep.
And then after that stress is out of there, then we move into, well, a lot of our customers, 80% of our customers will take the product as that.
Yeah. I can grab this, right?
Yeah. Yep.
So I mean, this is a standard barrel blank. You know, like if this was an inch 250 by 26 inches long and a 6mm hole, like this is what we would get, right? I mean, we could for sure take the mill finish off of this and contour it or make it, clean it up, put it on centers, etc. But that's a barrel blank. Yeah, and typically, like in your world, it's typically turn true, I call it. They just because we've got the machines with steady rests and support to turn a long barrel. So typically a gunsmith won't have that. So we'll put it between centers, turn that OD down from like 1 1/4 to 1.200, and then that's when it'll go to a gunsmith. And he can chuck on it, he can crown it, he can do whatever
they want. Yeah, exactly. So that's typically how they're going.
That's awesome.
Yeah.
So, all right, this 458 barrel, what's going to happen to that?
Well, it gets burned, like we said, it gets stress relieved, and then that'll go in a lathe.
Okay.
And it's got to get machined down.
Okay.
So
that's kind of like that barrel that we were looking at in the conference room there, where it has the contouring on the outside and all that, right? And it could be for a lever gun, could be a bolt action, it could be an AR, it could be any of that.
Yep.
Cool.
So so we're doing contouring here. So it might be good to kind of just check out.
Yeah, let's take a look here.
We queue up the barrel blanks here, and we just stack them up, and then we've got one of the newer Fanuc CRX robots.
It's a collaborative deal, right?
It's a collaborative.
Yeah,
that's why we can stand here.
Yeah, exactly.
Yep. And it'll grab it, put it in the machine, and then the machine will do Just want to make sure I don't screw up the program.
Put it back in the right spot.
Yeah, the guys get nervous when I'm out here. It does all the contouring, threading, muzzle, chamber, threads, everything.
That's crazy.
Yeah.
Everything. That's a complete.
Yeah, it's pretty unique to go from a blank to finished.
Yeah.
But we've kind of spent a lot of time developing it.
Yeah. Well, and you're using, careful. You're using high technology and a really advanced machine here to be able to put the chamber in and have this actually headspace the same. And that's that's the same type of thing that our action manufacturers that are making actions. Well, I would say 10, 15 years ago, maybe 15, 20 years ago, like our actions weren't held to the tolerances they are today, right? And certainly the barrels weren't done that way 15, 20 years ago. But with actions being held to really tight tolerances, we can use a really good machine, good tooling, probing, all of that, right? We can now put a chamber in, right, to those same tolerances. So end customer here should be able to just drop this onto their action and go.
Well, a great example of that is like all our bighorn actions, right? You got me onto them, and essentially that barrel that you have on your rifle, if I have a test barrel for not your action, but just a bighorn TL3,
or impact same way, some appliances,
it's within a thou. And we can hold a thou on chambering in thousands. And it's hard to do. It's hard to do, but
again, it comes back to that process and making a few 100,000 barrels a year. You figure it out, right?
You're forced to do it, So this is kind of a twin turret, twin spindle machine. It's pretty involved.
Get out of the way here. This is good timing. Moving kind of slow, right? But that's because it's collaborative, and you want to. I mean, it has to be safe, right? Like if I went up and grabbed its wrist, like it would probably stop, right? I'm not going to do that. But
you don't know right exactly. But,
that's cool.
So just having a machine tended as soon as it's ready, even if this is a little bit slower than our owner would like to see it, it's still it's very productive. It's very
productive.
consistent.
Yeah.
And we find that like automated systems, the tooling seems to last longer.
Yeah.
It just, and I'm not trying to knock like a manually loaded process, because there's things that we definitely want manually done.
Yeah. Oh yeah.
And we're just shifting more towards having a heavier staff working on developing automation and dialing in like these processes, the process for this machine.
Yeah.
Because that's a very, very complicated.
Yeah, there's a lot going on there.
Yeah, I mean, there's two screens there, so it's essentially running two programs, and you have to sync those two programs together, the G code, M code, and it's very involved.
Yep. No, that's very cool.
Yeah. So there's different gauging and everything that comes in with this. Yeah.
That's cool. Yeah, this is exciting. It's good to be back here, man. It's cool to. I don't know. This is what my passion was before the PRS. So it's very cool to be back and seeing the machines put to use and seeing the automation and technology you're putting in. So
yeah. I mean, so sometimes with some of these, you may have to do lapping too.
Yeah.
So we kind of talked about the 400 series, 300 series.
Those are lapped, right?
Those are lapped.
400,
Yeah. So that's a little bit of a.
So we might take this barrel here and go to lapping.
Yeah, I mean, typically we're going to be lapping in a barrel blank form.
Yep.
So after it comes out of the furnace, we're going to pour lead down it with a rod, and then we're going to go back and forth and lap it. So like any barrel for PRS, for the PRS world's all going to be lapped.
Yeah, right.
But you can really feel when you're lapping, you feel like these highs and lows.
Yeah.
And you're taking a lot of those highs and lows out.
Yeah.
And you're you know, we talked about honing changes the bore, 2/10, 3/10. Lap does kind of the same thing.
Yeah.
It's 2 to 3/10 that you're removing.
Yeah.
But now that lap being longer and having like sandpaper on it, you're smoothing out any highs and lows.
Right.
So it really changes the performance of the barrel.
Well, it's not actually sandpaper. It's just a little abrasive, right? I mean, it's any of the sort of manufacturing marks or you know, any of that stuff kind of gets taken out, smoothed out.
Yep. Any of the tool marks, the reaming marks. But even when that button gets pulled through there can be some highs and lows. On diameter, it takes all of that out.
That's cool.
So it takes most of that out. Yeah.
Heck yeah. Is there anything else you want to show us here while we're here, man? That's pretty cool. How many total cells do we have running? Just kind of like that cell one that we looked at.
So we've got 4 cells.
Yeah.
And then 2 of them are manually tended. And there's strategy behind that.
Sure.
The manually run cells, we run our higher end barrels. Like the 300, 400 series get ran on the manually.
Yep. And maybe a smaller quantity or something too, right? Kind of depends order by order,
runs.
right?
Yep. But like your like that lever action barrel, that's a 200 series barrel. Making thousands of them. You don't have to have a human looking at every single one of them all the time. Whereas like our 400 series barrels, we bore scope every single one of them. We really are careful with every single barrel that we're making.
Just take a little bit more time.
So, and then we have a far cell where it's fully automated. So the rifling is in the automation as well. This one, we have it out.
It's hand rifle. They are hand loaded by an operator. Exactly.
But there's certain things that we do with human intervention on the rifling, it makes sense to have it that way.
That makes sense.
And then the fully automated one, that just pumps out like a lot of AK barrels, a lot of AR barrels. So it just and it can just pound them out.
That's cool.
And then we got the furnace down there.
Very cool.
Things like that.
Man, I appreciate you having us here. Like I said, I love being back in here, and it's awesome to see manufacturing happen and and actually be in a shop. And especially in our industry, man, we have an awesome industry, and I love being a part of it. And I love the relationships and the partnerships we have. So.
Yeah, for sure. It's definitely a cool industry, and like people don't like push hard on competition or anything. We work together. Absolutely. If you come back in a year, things are going to be moved. There's going to be more robots. I mean, we keep
constantly
growing.
Innovating.
You kind of have to. So So, yeah.
Right on.
Appreciate it, man.
Chad,
All
thank
right.
you.
Take it easy,
We'll see
buddy.
you. Thank you.
Yeah.